Physicists say that the universe had its origin in an event known as the Big Bang approximately 13.7 billion years ago. However, the question that arises is what caused that explosion and why it occurred. Over time, we have been researching and studying the science and history of our universe, and the Big Bang has been the predominant explanation for everything we have observed. There have been countless studies and thousands of scientists have worked on the research, and the data collected has always supported the Big Bang theory as the main explanation for how the universe was formed. According to this theory, dark energy is a form of energy even more abundant than galactic energy, and it is considered the anti-gravitational force responsible for the continued expansion of the universe since the Big Bang. Science today is very different from what it was in the past, and with technological advances, new theories emerge. Many times we discover that things we thought to be absolutely true are far from being so. Michio Kaku has raised the official debunking of the Big Bang. This is because the James Webb Space Telescope has detected 750 new galaxies that look nothing like it was expected. This raises a new perspective and leads us to dwell deeper into how the James Webb Space Telescope is changing our understanding of the universe as a whole. Join us on this incredible journey beyond the far reaches of the observable universe to discover more details about the immense number of new galaxies that have been discovered. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video, share it to reach more people, and turn on the notification bell. The images of new galaxies captured by the James Webb Telescope are absolutely stunning. In a single image, we can see hundreds of galaxies all together, and the beauty and power of these photos are stunning, something that cannot be overlooked. However, what seems to amaze the average person is precisely the opposite for researchers. These images are amazing to them, but they do not match what scientists expected to see based on their theories. In fact, many more galaxies are being seen than expected, and these galaxies are different from the rest. They are smaller than imagined and have truly remarkable age. These surprises are generating some panic among scientists. There is even an article that begins with the word panic in its title, which shows the seriousness of the situation. These galaxies are nothing like they were supposed to be according to established theories. For a long time, scientists have proposed the Big Bang theory as a main explanation for the origins of our vast universe. According to this theory, approximately 13.7 billion years ago, the universe began its existence through some kind of mysterious cosmic event. However, these images challenge the definitive story of the birth of the cosmos as previously understood. The striking images captured by the James Webb Telescope has challenged our understanding of the origins of the universe. Specifically, these images directly contradict the Big Bang hypothesis, which has long been considered an unquestioned truth by most cosmology theorists. The galaxies captured in these images appear to be small, smooth, old, and numerous compared to the predictions of the Big Bang hypothesis. The fact that the observed galaxies are 2 to 3 smaller than similar galaxies imaged by the Hubble Space Telescope completely defies the expected behavior in an expanding universe. According to the hypothesis, as the universe expands, objects should appear larger as distance increases. However, these James Webb observations show galaxies that defy that expectation. Moreover, the smoothness of these galaxies is totally unexpected. According to the Big Bang theory, galaxies should show irregularities and variations in their structures due to the dynamics of their formation and evolution. However, the images reveal unusually smooth galaxies without the level of complexity and roughness that one would normally expect to see in galaxies of their age. This defies the expected time sequence for the formation and evolution of galaxies within the framework of the Big Bang theory. At the beginning of the universe, all matter, energy, and building blocks of the cosmos were compressed into an extremely concentrated point called a singularity. At this point, the density reached an infinitely high value due to the extreme compression of matter and energy. The concept of singularity is based on our current understanding of the laws of physics, especially the equations of general relativity proposed by Albert Einstein. Within the singularity, all matter and energy in the universe existed in an extraordinary compressed form. This extreme density implies that an enormous amount of mass and energy was concentrated in an infinitesimal space. Under extreme pressure and density conditions, such as those present in the singularity, heat is unimaginable. The temperature within the singularity would exceed any temperature observable or reproducible in our current understanding of the universe. The energy stored in this hot, dense point was the seed from which the entire universe as we know it today originated. The singularity marked the beginning of the universe, the origin of everything in our cosmos. After the initial singularity, the universe began its journey of expansion and inflation. This process occurred over approximately 13.7 billion years, giving rise to the universe as we know it today. The expansion of the universe began within an extraordinary rapid burst known as the cosmic inflation. During this phase, the universe expanded at an unimaginable speed, far exceeding the speed of light. It is as if the very fabric of space stretched and stretched, pulling everything within it with it. Cosmic inflation played a massive role in the formation of the large-scale structures of the universe. It smoothed out irregularities, homogenized the distribution of matter and energy, and paved the way for the subsequent formation of galaxies, stars, and other cosmic structures. As the universe continued to expand, the rate of the expansion gradually slowed. It is important to note that although there was a rapid cosmic inflation in the initial period, the universe continued to expand at a measurable rate. This steady expansion is known as the cosmic expansion or the expansions of the universe. Scientists have observed the effects of this expansion through various observations, such as the redshift of light from distant galaxies. Redshift indicates that as the universe expands, light waves are stretched and shifted to longer wavelengths, moving them towards the red end of the spectrum. During this expansion, all the stuff that make up our universe was compressed into an incredibly small volume. It was clear that matter could not survive in such compact space, so transformations occurred as the universe expanded and cooled. Particles such as protons, neutrons, and electrons began to interact with the light and energy around them. These interactions played a key role in the formation of matter in the universe during the first minutes after the Big Bang. This process is known as the nucleosynthesis. Chaotic and disrupted galaxies due to multiple collisions were expected to be observed, but the images captured by the JWST tell a different story. Instead of chaotic galaxies, the images revealed well-organized disks and spiral structures, similar to the galaxies we see in today's universe. This unexpected observation challenges the idea that mergers are a common process in galaxy evolution. If these new galaxies have not experienced many or any mergers, it becomes unlikely that small galaxies will grow and become hundreds of times larger as expected. This implies that these galaxies were never small originally. Furthermore, the optical illusion predicted by the expanding universe hypothesis, where objects appear to be smaller due to expansion, does not hold in this case either. Therefore, what we have believed so far turns out to be a falsehood. In addition, the age and abundance of galaxies revealed by the James Webb Space Telescope also challenged the validity of the Big Bang theory. The GWS is equipped with filters that allow imaging in the infrared part of the spectrum, which facilitates the study of the colors of distant galaxies. By analyzing these colors, astronomers can estimate the age of stars and galaxies. The James Webb Space Telescope has captured an image of a galaxy called GLAD Zeta 13, which has broken the record as the oldest galaxy ever observed by astronomers. This galaxy formed approximately 300 million years after the Big Bang, since it began operations on July 11. The telescope has amazed scientists with its clear images and fascinating discoveries. These findings include the detection of an exoplanet with the right conditions to support life, as well as an image that spans 1/5 the diameter of the Moon and shows us Jupiter's rings in greater detail than ever before. What exactly does this image provided by the James Webb Space Telescope represent? What will this impact on our cosmological research as we know it? Stay with us until the end to learn all the details about this latest shocking revelation. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. The James Webb Space Telescope has many advantages over the Hubble telescope. For example, the James Webb is located at a distance of about 1.5 million kilometers from Earth, 4 times farther than the Moon. This means that there is no interference from space stations or satellites that could affect the images obtained by the telescope. On the other hand, Hubble is only 547 kilometers from the Earth and can observe mainly in the visible and ultraviolet bands. In addition, the James Webb is equipped with NIRCam for the near-infrared and MIRI-Cam for the mid-infrared spectrum, while Hubble does not have these tools. This makes the telescope so powerful that it could even detect a bumblebee fluttering in space at the distance between the Earth and the Moon. The JW's infrared vision also allows it to observe the edge of the universe, where galaxies and older stars are found that might otherwise go undetected. The Hubble Space Telescope has limitation in its ability to see beyond the veil of gas and dust that surrounds planets, stars, and galaxies. In contrast, the James Webb Space Telescope is able to do this with ease, as if it had an X-ray beam. One of the main differences lies in the size of the James Webb mirror, which measures 65 meters in diameter, allowing it to absorb much more light than Hubble. In fact, this is the largest mirror ever sent into space and nearly 3 times larger than Hubble's 25-meter mirror. Thanks to this unique technology, the first images obtained by the James Webb Telescope were surprisingly clear. Even faintly luminous objects were visible. In fact, the deepest and clearest image of the early universe to date was captured by the James Webb in a single day, while Hubble took several weeks to collect similar images. The deep field image captured by the most expensive telescope in history shows thousands of galaxies, demonstrating its superior ability to explore space. At the center of the image is a group of galaxies that make up a cluster called SMACS 0723, whose collective mass acts as gravitational lens that bends the light from more distant galaxies behind it, causing it to warp. The James Webb Telescope has been able to detect many galaxies that have never been seen before by any other telescope. The James Webb's starting point was our solar system, where it captured the image of Jupiter while it was in the testing phase. Since then, the telescope has taken numerous images of the gas giant, demonstrating its exceptional capability. The images clearly show the planet's famous stripes, which are the result of complex atmospheric phenomena, as well as the Great Red Spot, a giant storm 16,000 kilometers wide, large enough to engulf the entire Earth. Jupiter's satellite, Europa, can also be seen in the image, as well as other moons. The James Webb Telescope also managed to capture images of Jupiter's rings, which is an incredible achievement because they are so faint and difficult to distinguish near bright objects in space, including the planet itself. The telescope then turned its attention to the exoplanet WASP 96b, which is at a very far distance from us, and managed to obtain surprising results. Scientists discovered that it is a gas giant with a mass less than half that of Jupiter, but with a diameter 12 times larger. The exoplanet is as puffy as cotton candy and revolves around its star much closer than Mercury does to the Sun, heating it to more than 1,000 degrees Celsius. JWST recorded the presence of clouds and haze in the planet's atmosphere and detected traces of water indicated by certain gas molecules present in its atmosphere. Scientists were very pleased with this valuable discovery, especially after the Hubble Space Telescope searched for water for the past 2 decades and was only able to detect it in 2013. This is intriguing, but not as exciting as finding extraterrestrial life forms on WASP 96b. The discovery of biologically significant substances such as water, oxygen, carbon dioxide, and methane is the first step on this path. If these substances are found on rocky planets, it will be a clear signal to start looking for signs of life there. Another image captured by the JWST shows the Southern Ring Nebula, which is 2,500 light-years from Earth. This nebula surrounds a dying star, and it is composed of at least 8 layers of gas and dust that have been ejected by the lower star. The bright central star mixes these emissions to create complex rings of planetary nebulae, similar to how sunlight on Earth illuminates the gaps in clouds. Previously, the Hubble telescope had captured stunning images of the Saturn's ring and many other nebulae, allowing us to see that these are not simply clouds of gas, but complex and colorful systems. However, the James Webb has done an even better job of providing an even more detailed image of the planetary nebula, as well as a much broader view of the space behind it, which is filled with many galaxies. Compared to the Hubble image, the James Webb image is much more detailed, and the bright stars in the Hubble image have 4 rays, while the stars in the JWST image have 6 points of light. This is because Hubble has round lens with a secondary mirror hanging in front of it in 4 extensions, while the JWST lens is composed of 18 hexagonal mirror segments. Now, take a look at the stunning image of the purple maelstrom, that is the spiral galaxy NGC 628, also known as M74, located in the constellation Pisces, about 32 million light-years away from Earth. Why is this image so different from the Hubble image of the same galaxy? The reason is that the James Webb telescope had a different task: to make a detailed analysis of the threads of dust and gas that block the lights from most stars, allowing us to see the aftermath of supernova explosions and star formation zones, which makes the image more dynamic. But let's not stop there. Let's take a look at another impressive image. It is the largest image taken by the JWST and covers about 1/5 the diameter of the Moon. It shows a compact group of galaxies known as Stephan's Quintet in the constellation Pegasus, about 290 million years away from us. The image of Stephan's Quintet captured by the legendary James Webb telescope shows 4 of the 5 galaxies approaching, colliding and dancing together in a gravitational dance, while the 5th galaxy observes at a distance of 40 million light-years from Earth. Although the Hubble telescope has also allowed us to admire Stephan's Quintet, the James Webb image offers new detail and was created from nearly 1,000 separate images, totaling more than 150 million pixels. The image reveals bright spots of distant galaxies in the background, as well as entire regions of star formation, and broad tails of gas and dust and stars ejected from various galaxies due to gravitational interactions. Huge shockwaves can also be seen as the galaxy NGC 7318b passes through the cluster. The galaxy NGC 7319 has an active supermassive black hole at its core, and the James Webb telescope was able to see beyond the dense layer of gas and dust at the center of the galaxy. The telescope discovered hot gas near the black hole in great detail. In addition, the image of the cosmic cliffs revealed a young star forming region called NGC 3324 in the Carina Nebula. Intense ultraviolet light and stellar winds from extremely massive young stars have sculpted the wall of the nebula. Experts were once again surprised when comparing the Hubble and James Webb's images. The image produced by the JWST is much clearer, which is especially noticeable when superimposing the images from both telescopes. In the image, you can see bright spots in the background, not only stars, but also very distant galaxies. The blue haze that appears to emerge from celestial mountains is actually hot ionized gas and dust ejected from the nebula by the continuous radiation from the young stars. One of today's most prominent and advanced physicists has expressed his opinion on the matter. Michio Kaku, recognized for his outstanding contribution to the fields of physics, has recently confirmed that the James Webb Space Telescope has discovered 6 massive galaxies that scientists thought could not exist. These investigations have the potential to open up new dimensions in our scientific understanding of the universe. It is therefore exciting and worth keeping an eye on these developments. Michio Kaku is an outstanding figure in the scientific field, a physicist of American and Japanese origin. He is considered an expert in both classical experimental physics and quantum mechanics. Unlike some more conservative and skeptical scientists, Kaku does not belong to that group and has been receptive to the amazing results of the James Webb Space Telescope mission. We are delighted that this distinguished scientist has decided to break his silence and publicly share what can no longer be denied. The enthusiasm and almost amused tone of the renowned stellar physicist is evident in his comments on the discovery made by the James Webb Space Telescope, expressing that this has been the highlight that has piqued his interest. Join us to discover the implications of Michio Kaku's discovery of these 6 massive galaxies. Michio Kaku is a scientist who has always been willing to consider new theories throughout his life. He is aware that Einstein's equations of relativity and Newton's law are insufficient to capture the full complex of the universe. Kaku understands that the discoveries of the new telescope have the potential to enrich the scientific field. Although many of his colleagues have not been able to adopt this view, it is generating concern and insomnia about the Big Bang proponents and opponents of quantum mechanics. However, this only provokes laughter from Michio Kaku. The James Webb Space Telescope has revealed the discovery of 6 massive galaxies dating back to the earliest times of the universe. Each of these galaxies contain more stars than our own Milky Way, despite having formed only 200 to 700 million years after the Big Bang. The team astronomers who have made the discovery have dubbed these exceptional galaxies universe breakers because, if confirmed, they would revolutionize our entire understanding of the universe. Something doesn't fit here anymore. The Big Bang theory tells us that the cosmos was a hot mess after the initial event. The first solid objects took hundreds of thousands of years to form, and it took hundreds of millions of additional years for the objects to reach sufficient density and produce light. The formation of complex structures such as galaxies was assumed to occur much later. Some of the newly discovered galaxies exceed the Milky Way in size, and their immense luminosity indicates that they were probably forming hundreds of new stars each year, whereas our galaxy forms stars only sporadically. It remains uncertain exactly when the first galaxies formed. Researchers have not been able to determine this so far. The only thing that is clear is that initially there may only have been single stars or group of stars, which eventually joined together to form larger and larger accretions until dwarf galaxies developed. These small galaxies encountered other galaxies and gradually grew. According to previous theories, highly organized and massive galaxies could not only have existed at that time, which raises the question of whether the universe is much older than previously believed, or whether complex stellar and galactic arrangements developed much earlier. This circumstance is difficult to accept for conservative science, which still finds problem with this model, and some branches of physics vehemently refuse to accept this discovery and question possible errors in the age calculations. Michio Kaku was aware of this and had this to say: "There are many examples of old and false theories that stubbornly persist because of the prestige of some scientists. Many of these theories were only discredited when a crucial experiment revealed their falsity. Therefore, the fundamental work in any science, especially in physics, rests within the experimentalists, who keep the theorists honest. In fact, on Earth, we know very little about the true beginnings of the cosmos." The Big Bang theory was established in 1927, based on observations of the expansion of the universe. These data led to the conclusion that the cosmos originated from a single point and has been expanding ever since. At the time, it was difficult for people and scientists to conceive of a universe with a beginning and an end. The idea of a universe that had always existed and was infinite in time and space was beyond people's imagination. And even today, scientists still face difficulties in understanding it. However, it is important to consider these probabilities once again. These new demonstrations do not fit at all with what researchers have based for decades on the Big Bang theory. However, science has shown time and time again that reevaluation and openness to new ideas are an integral part of the scientific process, as it is the confirmation of certain theories and observation. When Einstein was a child, it was believed that the stars and planets were firmly fixed in the universe, and these particular structures occupied a defined space. However, we now know that everything in the cosmos is in motion. Planets orbit stars, stars move within their galaxies at hundreds of kilometers per second, and entire galaxies move rapidly through the cosmos, the fate of which we cannot yet even predict. Today, scientists are challenged to accept uncomfortable truths and to understand that theories are not only guesses and not absolute truths until they are rigorously tested or confirmed by accurate observations. The idea of the Big Bang arose from the realization that galaxies are moving away from each other, and this distance is proportional to the distance to Earth. This observation, known as Hubble's law, suggested that the universe was expanding. For a long time, elements such as cosmic background radiation and the redshift of light from distant galaxies and other cosmological structures seemed to support this theory. However, it is important to remember that in the past, people who believed that the Earth was flat and that the Sun revolved around us also had circumstantial evidence for their assumptions, until coincidence or technological improvements came along that provided a clearer and more accurate picture. Right now, we are witnessing a similar situation. Scientists expected the new James Webb Space Telescope to confirm the assumptions related to the Big Bang. But instead, they have come across these 6 galaxies that seemed impossible. This reminds us that science is constantly evolving and that scientists must be open to new discoveries and rethink existing theories based on the available evidence. Researchers use redshift as a tool to determine certain quantities in the study of the cosmos. Redshift, also known as the Doppler effect, refers to the change in the color of the light as the light source of the observer move relatively to each other. To understand this, you can imagine standing still and seeing a car coming towards you. As a car moves towards you, you hear the sound of the engine getting louder. However, once the car passes you or moves away from you, the sound of the engine changes. This is because the sound of the engine varies as the car moves. The same is true of light. When a light source, such as a distant star, moves around us, the light we perceive shifts towards bluer hues. On the other hand, when the light source moves away from us, the light shifts towards redder hues. This phenomenon is called redshift. Physicists have converted redshift values into velocities and distances for measurement in the study of the cosmos. However, it is important to note that small errors in these measurements could have significant effects. The measurement techniques previously used are currently under review, and it is interesting to see what results scientists will arrive at. As for the latest demonstrations related to our cosmos, it is necessary to consider whether they are really based on redshift errors or whether some scientists are simply denying the facts. This is a question that requires rigorous analysis and careful review of the data and methodologies used in the research. Thank you very much for watching the video. As always, we remind you that you can post your doubts in the comments box. If you liked the video, do not forget to hit the like button, share it so it reaches more people, and subscribe to the channel so you don't miss more content like this. Thank you so much for watching, and see you in the next one.